Hi guys, welcome back to Mathematics for Engineering 3. Hope you guys haven't been so bored of me yet. Okay, today in this video we are going to be talking about Riccati uh, equation. It is another type of ODEs. Okay, it looks pretty much like a linear equation, but it's not linear. Okay, and it looks very similar to the Bernoulli as well. So let's start. We're gonna look at the the form first. So the first order differential equation in this form, where p, q, r are functions of x, is called a Riccati equation. Okay, guys, if you look at the equation, this equation, you can see that if px is 0, it's actually linear. And if rx is 0, it's actually a Bernoulli. Why? If you don't remember, you look at the forms. The form of the linear equation is actually dy, right? When y is the dependent variable, it's dy plus some function of x, y dx equals some function of x dx, right? And that is the linear equation. So if you see here, if px is actually 0, okay, I can, write it in the differential form. So it's gonna be dy equals this guy dx and this guy dx, isn't it? Right? Basically, I can push the x over there. Okay, so if this is 0, you have dy and you have some x, y dx. See? And you have rx. Okay, rx dx, which is this, which is this guy. See? But if rx is 0, so if you don't have this term, it's going to look like a Bernoulli. So what is Bernoulli? In the previous video, we talked about the Bernoulli equation, which is dy plus some function of x, y dx equals some function of x, y to the n dx. So if this is Bernoulli, so if rx is 0, you're gonna see that you have dy, which is this guy, and you have qxy dx, which is this guy. Okay, and then you have px y squared dx, which is this y, this one. So it's the Bernoulli when n equals 2. Okay, so you need to you need to be able to tell whether or not it's linear, is Bernoulli, or is a Riccati equation. Okay. Okay, guys, in exam we won't tell you, okay, which method you should use. So when you see the problem, you need to be able to tell which method is suitable for that particular problem. Okay, so what that can help you is doing exercises. Okay, once you see lots of exercises, you see lots of questions, you will be able to tell, okay, this one is linear, this one is exact equation, this one is separable, this one is a equation when the coefficients are linear equation, and this is homogeneous. You will be able to say, okay, you'll be able to tell, but only when you do enough numbers of exercises. Okay, so guys, do exercises. Okay, otherwise this course is going to be so hard for you. Okay, it's going to be so hard for you if you don't do exercises. Okay, well, so to solve a Riccati equation, we need to know at least at least one solution. And that is the good thing. That is the good thing. Why? Because, whenever you see a question with one solution, they give you an equation, an ODE to solve, and then they give you one solution. You know that you need to solve it by Riccati. Okay, makes sense? Makes sense? Because, for some other methods, they only give you the ODE, right, to solve, right? Or they can give you the initial condition, right? But here they will give you one solution. Okay, they'll give you one solution, so you'll be able to differentiate between the other methods and the Riccati. Okay, so let's have a look at how to solve this particular problem. So first, this is nothing but a Riccati equation. So in order to solve it, as mentioned, we need to know one solution. So I let y1 be a solution. Let y1 be a solution. So if y1 is a solution, back to the first video, we talked about, when y is a solution, it needs to satisfy this ODE, right? So if y1 is a solution, we know that dy1 by dx equals px y1 squared plus qx y1 plus rx. We know that is correct because y1 is one of the solutions. So if you substitute y with y1, it needs to be true, isn't it? Right? Okay. So the method is that first we will substitute v equals y equals v plus y1. Okay, when y1 is the solution. Okay, v is a new variable. Okay, so basically we substitute y with v plus y1. So whenever we see y, we put v plus y1. So we put it in there. Okay, so we have here v plus y1 squared, which is y squared, right? And then qx y. So we put v plus y1 in there instead of y. Okay, and then this is nothing but this is nothing but a plus b squared, which is a squared plus 2ab plus b squared, right? That's the secondary school formula. So you have that is v squared plus 2vy1 plus y1 squared. Okay, and this is nothing. Just copy it down. Okay, and then I just distribute this term and I get this. And then I just rearrange things. Okay, I just rearrange things. So basically, this guy is this guy. Stay there. Doesn't move at all. This guy, and this guy, they stick together. Okay, this guy and this guy, they stick together here. Okay. Oops. Sorry, it's not that guy, it's this guy. Okay, so they stick together. Okay. And this guy moved here. This moved here and this moved here. Okay. But guys, as we know that pxy1 plus qxy1 plus rx is, what is it? Here, right? It equals to dy1x. So that's why we have, dy1x here. Okay. Okay, and because of that, dy1x, dy1 by dx are cancel out. Okay, so this is the equation that we have. This equals this. Okay, and then we multiply the x up there, and then we moved it to the left hand side. Okay, so this is what we have. Okay, so here is this guy stay here, this guy stay there, and then we move this guy. Oops, sorry, I use some other color. We move this guy to this side, so we have the minus sign here. Make sense? Okay, basically we multiply the x to that side, so we have the x here, we have the x here, right? And then we keep this here, we move this to the left hand side, we get this. Make sense? And this equation, if you look closely, it is actually a Bernoulli equation when n equals 2. Why? You look here. Right now, our y is actually v, right? V is actually the y. Okay? So, we have dy, and we have, I don't know, some x. Okay, and we have one y here. And then we have y squared with some x. It looks pretty much like the Bernoulli. See? So it becomes Bernoulli. So we can find the solution v. Okay, so once we find the solution v and the solution of, you know, this equation, the solution of this equation is actually v plus y1, right? Because our solution is actually y, right? Our solution is actually y, right? Because we want to know y, but we let y be v plus y1, but y1 is known because it's a solution, so it's known. So from this equation we can get v, we can solve for v. So when we get v, the solution will be v plus y1, which is the y that we want. Okay, so let me sum it up. First, when you see this equation, you substitute y by v plus y1. After that, you will end up with this equation. You can solve that equation for v, and after that the solution would be v plus y1. Okay, let's look at an example. Here, see, we have that y1 equals 1 is one of the solutions. See, we have y1 equals 1 is one of the solution. See, this is guys, this is not initial condition. Okay, it's not an initial condition. If it's an initial condition, you would get like x equals something, like x equal 1, y equal 1, or you know, stuff like that. Or I don't know, y1 is 1, or I don't know, fx is 1, or you know, those kind of thing. But here, y1 here, it doesn't mean that it's y1 when x is 1. No, it's just the name. It's like y number 1. It's like the first y. Okay, it's just a name. It's not y when x equals 1. I can change this to, I don't know, y bar equals 1. It's a solution of, it's one of the solutions. Or I can change it to y star equal 1. Or I can change it to y, I don't know, ya equals 1. It's just the name, okay? Okay, just the name. It's not that y when x is 1, okay? So it's not an initial condition. So when you see this kind of problem, you know that it's Riccati equation. And to verify that, see guys, you have, you know, some x here, and then you have y squared, and then you have another some x here, and then you have y, and then you have just some x, see, which is exactly the same as the Riccati. See, you have some x, you have y squared, you have some x, you have y, and then you have some x. See, some x, y squared, some x, y, some x. See, you can see, you can put the stress on this guy. Y squared, oops, sorry, y squared, y, and no y. See, here, y squared, y, and no y. See, so it's obvious. It's obvious that it's a Riccati equation. So how to solve that? First, I will let y be v plus y1. Okay, but our y1 is 1. So what we have is v plus 1. Okay, it's v plus 1. Okay, this is you know, our beginning. Okay, so I will just, you know, substitute y, which is v plus 1, into equation star. So what I have is d v plus 1 by dx equals 1 minus x y squared, which is v plus 1 squared plus 2x minus 1 y minus x. Okay, sorry, y is v plus 1 minus x. Okay, so you basically you substitute y by v plus 1. Okay, so what we have here is dv by dx plus d1 by dx, but d1 by dx is 0, right? It's the derivative of a constant, so it's always 0. So the next one would be 1 minus x v squared plus 2v plus 1 plus 2x minus 1 v plus 2x minus 1 minus x. Okay, so what we have next is 1 minus x v squared plus 2 of 1 minus x v plus 1 minus x plus 2x minus 1 v plus 2x minus 1 minus x. Okay, so basically I just, you know, distribute this guy here. So it's just distribute this guy basically. Okay, and then I'll look at the term with v. So this is 1 minus x v squared. This term would be, you know, I'll take the sum of these two terms. So it would be 2x 2 minus 2x plus 2x minus 1 v. Make sense? This guy is 2 minus 2x. Okay, and this is 2x minus 1 v. Okay, plus 1 minus x plus 2x minus 1 minus x. So guys, look at this. This is 2x, this is minus x, so they got cancelled out. Okay, so here minus 1, 1, so they got cancelled out as well. See, and this guy got cancelled out. Okay, and 2 minus 1 is actually 1. So we have 1 minus x v squared minus plus v. Okay, so we have that dv, and then I just move this guy to the left hand side. Okay, I move this guy to the left hand side. So we have that dv is, okay, let me write it slowly. Minus v equals 1 minus x v squared. So we have that is dv minus v dx equals 1 minus x v squared dx. Okay, and this one is I'll call it equation double star, is a Bernoulli equation. Okay guys, if you substitute this in y, okay, in this y, and it doesn't become a Bernoulli equation, it means that you did something wrong. Okay, you need to go back and go and look back what you have done wrong. Okay, so if you have one solution and the equation here is Riccati, so when you substitute y equals v plus y1, which is plus 1 in this case, you're gonna get the Bernoulli equation for sure. Okay, you need to get a Bernoulli equation. So I could have stopped here, right? Because this is Bernoulli equation, and you are I think I assume that you are really familiar with it from the previous video. But anyway, I will still solve it for you guys, okay? Just to remind you guys of how to solve this equation. So first, I will let I don't know, we used v before in the previous method, right? In the previous method, these are y, right? These are y, and then we let v be y. We divided everything by y squared, right? So I'm gonna do the same thing. So I'll divide the whole thing by v squared. So I have I have v to the power minus 2 dv minus v to the power minus 1 dx equals 1 minus x dx. See? And then you remember we need to eliminate this guy, right? We need to eliminate this guy. We want it to be linear. Keep in mind, guys, we want it to be linear. Okay, we want it to be linear. And the linear is when you have some y here, or in this case it's gonna be z. Okay, so I let z be v to the power of minus 1. So dz is minus 1 v to the power of minus 2 dv. Okay. Okay. So dv is what is it? Minus v squared dz, right? Oops, sorry, I shouldn't have done that. And then I know that v minus v to the power of minus 2 dv equals minus dz. Why? Because I see this guy here. So I want to substitute this guy into this equation. And this is Bernoulli equation, right? We did it like a couple of times before. So we substitute that back into this this equation. So what we have is minus dz minus z dx equals 1 minus x dx, and then I multiply the whole equation by minus 1. So I get dz plus z dx equals 1 minus x dx. Oh, can I change it to x minus 1 dx? And then guys, this become linear as we want it, right? So when it becomes linear, we solve it by introducing an integrating factor, right? Guys, if you don't remember these things, okay, go back to the previous video, okay? We talked about how to solve the Bernoulli, we talked about how to solve the linear, and then we talked about the integrating factor. Remember? Go back to the previous video, okay, and study it, okay? So the integrating factor would be e to the integrate. This guy, we're gonna look at the, the coefficient of z, right? Before this, it might be like, px. But in this case, the px is just 1, right? You have number 1 here. So it's actually 1 dx, right? So it's actually just, e to the x. Okay, it's e to the x. This is the integrating factor. Let me call it u. Sorry, I forgot to write u equals. Okay. No, not u, sorry, mu. And then we find d mu is actually what? E to the integrate 1 dx. And then we have d1 here, right? Which is d of the relative of this, which is just dx. It's actually 1 dx. Okay. So it's actually mu dx. Okay. Or you can just look at it from here. If you want to get d mu, is d of e to the x by dx, right? So it's, e to the x is e to the x dx, which is mu dx. Okay, it's the same thing. But I found it easier to, to use this integration. But if it's confusing in this example, you can just go back to mu equals e to the x. And then guys, what's next? We need to multiply mu, which is e to the x, to this equation, right? So what we have mu. Oops. I'll use, some other color. We have mu. Sorry, I'll multiply it to not that equation, but I'll multiply it to this triple star equation, which is this equation, when it becomes linear already. So is mu dz plus mu z dx equals mu x minus 1 dx. Okay, guys, but again, as we did many times, mu dx is actually dz. So we have that is mu dz plus z d mu. Okay, because mu dx is dz from here. Okay, oops, sorry, mu dx is d mu. Okay, from here. So mu dz plus z d mu equals mu x minus 1 dx. So we have that is d of mu z equals mu x minus 1 dx. So we have this guy is e to the x minus 1 dx. Okay, so what I have here is d of d of e to the x z, right? Mu is e to the x, is integrate, is e to the x minus 1 dx, and then we can integrate throughout the equation. Okay, and how to integrate this guy is integrate of e to the x minus e to the x dx plus c, right? Okay, I probably need a next page. It's pretty long, but it's not hard once you remember all the method that we have. Okay, my camera is dead, is ran out of battery. I'll get back live soon in the next, like, I don't know, 3 minutes. Okay, here, so e to the x z equals this integrate. Okay, first let me look at this integrate of e to the x dx. This one we need integrate by part. So we have x, we have e to the x, we have 1, we have 0, we have e to the x, e to the x. We did this many times, so I'm not gonna explain, right, the integrate by parts. If you don't remember, go back to the previous video. Okay, so it's like that, and then it's plus minus plus, right? This one you keep differentiate, and here you keep integrate. Okay, you keep differentiating, you keep integrating. Okay, so this integration is x e to the x. Oops, sorry, it's an error. It starts from here. My bad. Start from here. Okay, plus minus. So we have e to the x minus e to the x. Okay, and guys, integrate e to the x dx, which is, this part is just e to the x. So we have that e to the x z equals what is it, x e to the x minus e to the x. This is the first integral, minus e to the x. This is the second integral, plus c. Okay, so we have that e to the x z equals x e to the x minus 2e to the x plus c. Okay, and that is the solution when in terms of z, right? And then we need to do the substitution, because we let z be v to the power of minus 1. Okay, so what we have is e to the x over v equals x e to the x minus 2e to the x plus c. And after that, guys, it's not done yet. Our solution is y equals v plus y1, right? V plus y1. So our solution, we need to get v first. And we have that v is actually e to the x divided by x e to the x minus 2e to the x plus c. Right? Okay. And our y is actually v plus 1. Okay. Which is e to the x divided by x e to the x minus 2e to the x plus c plus 1. Okay. If you want, you can make it look a little better by, just it's done here. Okay, it's done here. You can stop here. But if you want, you can make it look a little better by doing this. E to the x, and here is e to the x minus 2 plus c e to the minus x, and then you have plus 1 here, and e to the x here got cancelled out. Okay, so your solution can be y equals 1, or you can say x minus 2 plus c e to the minus x to the power of minus 1, and then plus 1. You can do that as well. I'm not sure if it looks better. Okay, I'm not really sure if it really look better, but I hope it does. Okay, I hope it does. Okay, let me summarize this long problem here. First, we know one solution. Okay, we know one solution. So we let y be v plus y1, which is v plus 1 in this case. And then we substitute this y in this equation. Okay. So this is what we have. We just substitute it in, the equation star. After that, after rearranging the term, we get this equation. And then we get this equation, which is Bernoulli. See? So in this section, it's actually done here when it's Bernoulli. Okay? After that, when you want to solve the Bernoulli equation, first you divide this equation by v squared. Okay? By v squared. So you get this equation. And then you substitute z by v to the power of minus 1. Okay? So dz is minus 1 down here, right? dz is minus 1 down here, and then v to the power of minus 2 dv. Okay, so we have that v dv, which is this guy, is actually minus of dz. Okay, and then we substitute that in this equation. So we have minus dz minus z dx equals this. Okay, after that I multiply the whole equation by minus 1. So we get this equation. This is another checkpoint when it is linear. Okay, when it's linear, we think of the integrating factor, which is this guy, and then we multiply the whole equation, this equation, by mu. So we get this equation. Okay, and then we rearranging the term, we get this equation, right? And we get mu is actually e to the x, right? So we get e to the xz is actually this guy, and then we integrate, we get the constant here. Okay, so the problem is just to integrate this guy. Okay, so here the problem is just to integrate this guy. So to integrate this guy, I look at this guy first, and then I use the integrating by parts, and I get this, and integrate of this guy is this. Okay, and then we have that this is the solution, but it's in terms of z, right? This equation is in terms of z. So what I did was that z is actually v to the power of minus 1, which is actually 1 over v, right? So here we get z, which is v to the power of minus 1, which is the same as 1 over v. See, and again we solve for v, so I push v up there and I push this down, so this is a v. Okay, and the solution, as I told you before, the solution is y equals v plus 1. Okay, so that is the solution, y equals v plus 1. Okay, and you can just stop here. This is just to make it look, I don't know, prettier. That's it, nothing else. Cool. So let's look at another example. Okay, the next question. Solve this equation where y1 is minus e to the x is one of the solutions. Okay, again guys, we let y be v plus y1. Okay, in this case it's v plus minus e to the x. Okay, v minus e to the x, and then we substitute that into this equation. So what we have first, we look here first, is dy by dx, y squared, y, and just x. See, in front of y it's just x, right? 1 can be seen as x as well because there's no other y. Okay, so So it's Riccati equation. So I'll put that in there. So we have what is it? V plus V minus e to the x by dx equals V minus e to the x squared plus 1 plus 2e to the x V minus e to the x plus e to the 2x. Okay, basically I just substitute V minus e to the x, just put that in y. Okay, in this equation. See, and because of that we have that guys, here is dv by dx, and guys is my e to the x. Why? Because guys, d by dx of e to the x is actually e to the x. Make sense? That's why we have e to the x here. Okay, equals v squared minus 2 v e to the x plus e to the 2x, and then plus 1 plus 2e to the x v minus e to the x plus e to the 2x. Okay, and then we need to look at these terms, which are v squared minus 2v e to the x plus e to the 2x plus, and then I'll look at this term first, which is what? Which is v minus e to the x, and then I'll look at this term. Okay, when you want to multiply that, you need to do it this way, like 1 2 3 4. Okay, this is 1 and 2, so we need 3 and 4, which is 2e to the xv minus 2e to the 2x. Okay, and then we have plus e to the 2x. So guys, this is e to the 2x, e to the 2x minus e to the 2x, so they got cancel out. Okay, because e to the x plus e to the x, that 2e to the x, sorry, that 2e to the 2x, and then this cancel out with this. Okay, and this guy got cancel out as well. Okay, and this e to the x got cancel out with this. Let me use some some other colors. So here, this e to the x and this minus e to the x, they got cancel out as well. So the equation that we have left is quite simple, which is this equation, and then is dv minus v dx equals v squared dx, and you can see that is Bernoulli equation. See, so in this section it's actually done here. So how to solve this equation is back to the previous section. Okay, back to the previous video. Okay, so that's why I told you need to master each method step by step, because the other method is built on the previous ones. Okay, so to solve this, I will divide the whole equation by v squared, so I get v to the power of minus 2. Let me use some other color. Is v to the power of minus 2 dv minus v to the power of minus 1 dx equals dx. Okay, and then what I will do next, I think you know the answer. It is to let z be v to the minus x, right? Because we want to eliminate this guy. think of what I'm saying in the exam. Okay, we want to eliminate this guy, so we let that be set. So guys, dz is minus v to the minus 2. Okay, dv. So we have that v to the minus 2 dv equals minus dz. Is pretty much the same as in the previous example, isn't it? Right, we end up with pretty much the same equation. Okay, so here we have that minus dz minus z dx equals dx, and then I multiply the whole equation by minus 1, so I get dz plus z dx equals minus dx, and that is a linear equation. See, it turns to be a linear equation. Okay, and then what's next? I'll solve this. How? I introduce an integrating factor, right? Which is e to the integrate 1 d what? dx, which is e to the x. Okay? And I know that d mu is actually e to the integrate 1 dx, which is mu dx. So we have that this equation. If I multiply it by mu, I get mu dz plus z mu z dx equals minus mu dx. Okay, but mu is e to the x. So here guys, first before doing that, here is mu dx, and that is d mu. So it's mu dz plus z d mu equals minus mu dx. So we have d mu z equals minus mu dx. So we have that d e to the x z equals minus e to the x dx, and then we integrate, right? This got cancelled out. So we have e to the x z equals minus e to the x plus c. See, because right, integrate of e to the x is e to the x. Okay, but z is 1 where z is 1 over v, right? It's v to the power of minus 1, because z is v to the power of minus 1, which is 1 over v. So we have that as is e to the x divided by v minus e to the x plus c. So we have that v is actually e to the x divided by c minus e to the x. And again, we need to substitute again. Oh, sorry, we need to write the equation in terms of y equals v plus y1, right? Which is e to the x divided by c minus e to the x plus y1. What is y1? y1 is minus e to the x. Okay. And that is actually the solution. Okay. But guys, if you notice here, if you look here, this equation, of course, is Bernoulli. It's Bernoulli, right? That's why we did this, and then we obtain the solution, right? Because it's Bernoulli. But I will copy it. Okay, I will copy it, and then I'll just put it here. No, I'll put it into the new page, okay? I'll put it here. If you look here, I know it's Bernoulli, but if you look very, very closely, you will see that it's also separable. Okay? So if you notice that and you don't want to do the Bernoulli equation, right? If you don't want to do the Bernoulli, because the Bernoulli is quite long process, right? You need to divide the whole thing by v squared and then it becomes linear. And then you introduce the integrating factor and blah, blah, blah. Okay? So if you don't want to do that and you notice that this guy is actually separable. Why? Because if you look here, guys, if you look here, dv it would be minus v dx minus v squared dx equals 0. So we have dv minus v plus v squared dx equals 0, right? So we have, I divide the whole equation by v plus v squared. So I have 1 divided by v plus v squared dv minus dx equals 0, right? In that case, I can just even write it like this. You don't need to, but it might be easier to look at. So it's dx. So then I integrate this guy plus c. Okay. So now I need to find integrate of dx, which is x. That is easy, right? This integration, this integral is easy. It's just x, right? But how to find this integration? Integrate of 1 over v plus 1 dx. Someone might say that, okay, just do Bernoulli. I don't know how to integrate this function. You should know how to integrate this function, okay? It's something called partial fraction, okay? So first, you write this guy in terms of a divided by v plus b divided by v plus 1. And then you multiply the whole equation by v plus 1. V times v plus 1. So we have a v plus 1 and plus b v. So if you substitute v with 0, you get that is actually what? 1 equals a. So you have a is 1. If you substitute v with minus 1, so you have that is 1 equals minus b. So b is minus 1. So we know that 1 over v plus 1 is actually 1 divided by v minus 1 divided by v plus 1. So this integration is actually the integrate of 1 over v minus 1 over v plus 1, which I'll move this guy down, which are log of absolute v minus log of v absolute v plus 1. Okay, and then this guy is going to be log of absolute v minus log of absolute v plus 1 equals x plus c. Okay, but guys, what is v? V is the solution, right? V is the solution, right? So we need to find v. Okay, we need to find v. So if we want to find v, can I look at it like that? Log of first I will multiply the whole equation by minus 1. So I get log of v plus 1 minus log of v equals minus x plus c star. Okay, it's actually minus c, but it's another constant, so I don't really care. Okay, so I don't really care. Guys, I don't want to get a new page. So can I resize this? Okay. Be really small. Okay, and I keep it here. Okay. Yeah, because we don't need that anymore, right? Just how to do the partial fraction. So from there, I have that is here comes here. So we have that this guy is actually what? It's actually log of v plus 1 divided by v equals minus x plus c star. Okay, and that is v plus 1 divided by v equals e to the minus x plus v star c star, sorry. Okay, and I can call that e to the minus x and then c double star. Okay, let me write even more in details. Is e to the minus x times e to the c star, which is e to the minus x c double star. Okay, I look at e to the c star as another constant because e is a constant, c star is a constant, so e to the c star can be seen as another constant. Okay, and then this guy, it can be, okay, I'm not gonna write that down. Okay, I'm gonna just let you know. This guy, it can be either positive or negative because you have absolute here. Right? So v plus 1 divided by v. This guy, it can be positive and negative. Right? But guys, again, as in the previous section, c star here is a constant, right? So if this guy is positive, I can just remove the absolute out, and that's it. That's it, right? If this guy is negative, if I want to remove this absolute, I need to put the minus sign here, right? But the minus sign here will be included in this constant, so it doesn't really matter. Make sense? So that's why I can just remove the absolute. So this is what I have. C e to the minus x. Okay, I call the c star just c, just to make it simple. Okay, so we have that. Okay, I'm gonna remove my camera. So we have that v plus 1 equals c e to the minus x v. So we have that v minus c e to the minus x v equals minus 1. So we have v equals minus 1 divided by 1 minus c e to the minus x. Okay, or guys, do you know how it go from here to here? I just pull v out. And then okay, let me write that down. Just in case that some of you are confused. So from here, I pull v out, so I get 1 minus c e to the minus x equals minus 1. So I have that v is actually minus 1 times 1 minus c e to the minus x to the power of minus 1, which is c e to the minus x minus 1 minus 1, like that. Okay, cool. And then the solution y is v plus y1, which is v plus v is this guy, is c e to the minus x minus 1 plus y1 is minus e to the x, and that is the solution. And it's the same solution as when we solved it using the Bernoulli equation. Okay, so I'm not sure which one is easier, but you know, I don't know, you just pick whatever you can do. Okay, so and I think most of you guys will solve it using the the Bernoulli equation, because you know that once you have a Riccati equation, it's going to be reduced to Bernoulli, and then Bernoulli is going to reduce to linear, and you can solve linear by integrating factor, and that is quite simple. But if you look at this as a separable, you can solve it as well, and you're gonna solve it by this approach. Okay. And guys, that's it for this section. It's a Riccati equation. So basically, is a equation in this form. Okay, let me go back to the first page. It's the equation in this form. So you need to be able to recognize the form is px y squared qx y and then sum x, right? But the important thing, one of the most important things for this Riccati equation is that to solve it, you need to have at least one solution. You need to know at least one solution. So if they want you to solve an equation which is a Riccati equation, they will give you one solution. So if you are given in ODE to solve and one solution, you know that you need to use Riccati. Okay, so you just look at it and see whether or not it's Riccati, and it should be. Okay, if it isn't, look closely. Okay, and then once it's Riccati, you substitute y with v plus y1, right? When y1 is the solution. Okay, and then when you after substitution, that Riccati equation will become a Bernoulli equation. Okay, if you don't get a Bernoulli equation, see guys, you might have done something wrong. Okay, you need to get a Bernoulli equation for sure, 100%. And once you get a Bernoulli equation, right, you get y squared, you get the Bernoulli equation when n equals 2, then you divide the whole thing by y squared, right? And then you let the second term, which is z to the minus 1 be y to the minus 1 be z, and then you reduce that to a linear equation, right? So once you get the linear equation, you get the mu, right, which is the integrating factor, and then you solve that as it should be. Okay, I hope this is not too hard for you. Okay, guys, I know this is tough. Okay, there's a lot of things to learn. Okay, but it's not hard. It's just most of them is a labor work, right? You just need to keep working, keep writing, keep computing. And I know it's annoying, but it's not very hard, right? Once you notice the form, once you know that it's separable, once you know that it's homogeneous, you know that it's exact equation, once you know that once you know what it is, you know what form it is, then you can solve it pretty easily using the steps that I told you. Okay, but to be able to remember those steps, you need to do exercises. Okay, there's no other way. You need to do exercises, and all will become really clear and easy. Okay. And guys, if you have time, go back and brush up your integration techniques as well. Okay, how to integrate using integration by parts and the partial fractions, and the lots of techniques, integration by substitution, those kind of techniques that we see quite a lot in this course. Okay, and we actually assume that you are you have mastered those techniques already. Okay, so guys, fighting. Okay, we're gonna get through this semester together. Okay, none of us will be left behind. Okay, we will fight through the final. Okay, so see you guys. Bye bye.